RavenDB is built to be your main database. It's the system of record where you store all of your information. To minimize complexity, work, and cost, RavenDB also contains a fully-fledged full-text search engine. You can perform full-text searches, but you don't need a plugin or add-on. This enables you to find interesting documents based on quite a lot of different criteria. By default, queries in RavenDB are case insensitive, which saves you time by making it easier. You can search for a particular term or terms over a set of documents and find results without having an exact match. You can use commands like StartsWith and EndsWith to sift through your data with just a bit of information about what you're looking for. Using automatic indexes, RavenDB doesn't have to go through your entire result set to get you what you want. Most of the work is already done during the indexing process, making your text queries really fast. As an ACID database, indexes are safe from corruption. Being ACID for over a decade, RavenDB can deliver this data integrity without compromising performance. Today, RavenDB CEO Oren Eini will show you all sorts of really cool features that help your database find exactly what you're looking for. You will discover how to find documents that have terms similar to the specific term you're querying, finding orders that are similar to a particular order, given a particular word like queue or queuing up, how to find other permutations of the spelling of that word by suggesting possible misspellings of the word, indexing data in multiple languages, and highlighting data throughout lots of text. Feel free to ask questions by clicking the Q&A button at the bottom of your screen, and Oren will be happy to answer them throughout the session. Enjoy your presentation, and here's Oren.
Hello, everyone. Thank you for joining me for this webinar. As usual, it's a pleasure to have you here, and I would dearly love it if you ask questions. You can use the Q&A option, you can use the chat. Either option would be just great for us. And one of the primary features of RavenDB that we don't actually really talk about is that it is able to do quite a lot with your data. And what do I mean by that? I mean that once you put data inside of RavenDB, then you're able to query on that in many interesting ways. Let's look at this. And this is what you typically think about when you talk about queries. Give me all of the users with a particular emails or that have a particular birthday. By the way, if you have users in those state range, my condolences, they are going to cry a lot. But anyway, those are simple queries. This is a binary property. Is it much or is it not much? In many cases, this is where you stop. This is what the system record for. And then if you want to do other stuff, you go and have to integrate other solution. Solar, Elastic, Phoenix, and those sort of things. Sphinx, sorry, not Phoenix. And with RavenDB, you don't need to do any of that. So let's talk about what sort of queries do I want to be able to do. And typically, this is what it looks like. When I had to ask the users, what do you want? Oh, I want to be able to find data. Okay, based on what criteria? Sort of like this. It had a round shape, those sort of things. And that's me trying to figure out how to just, what do you want me to do? And this is, I think, sums up where we are the most. Now, at one point, I got a very, very clear specification from a customer. They told me I wanted to work exactly like Google. Google, and sometimes you do that, you search for something, and Google find you what you meant. Not what you search for, but what you meant to search for. And that's awesome, and it's scary at the same time. So it turns out that asking for the Google budget isn't really a viable option, unfortunately. We have to do it slightly less than that. But there are quite a lot of techniques that you can apply that make this approachable and easy. So let's look at things. In order to actually work with a realistic data set, I went to Enron. If you're not familiar, one second. If you're not familiar with Enron, this used to be a big energy company. Apparently, they got into big trouble with the law and the court system and financial fraud or something like that. What is interesting from our perspective is that what happened was that part of the court proceeding, they dump all of their emails into the public records, which means that this is very commonly used for full text search studies. So let's go here. This is my Enron database. And this is the primary thing that we care about. What you can see here, this is basically just emails. And apparently someone had a pretty bad day and they wanted something. Apparently they really had to migrate it in 2001, just to give you some idea about what's the time frame. And that's the data set that we have. This has actually been used quite extensively as a corpus of real world data that you can work with and play around. And it's really interesting to just go and figure out and see what's going on. By the way, this is a nice feature in the studio. If you have data like this, which is a long text field that has lines, you can say toggle lines and just read it much more easily than you would usually, and then just fix it back because that's not a valid JSON string. And with this, we want to start running some queries, doing some interesting things. So let's talk about what we can do. The first thing that I want to be able to do is just ask questions about the email itself. And you can see here that they have a subject, body, where it was at, a whole bunch of other stuff like that. Let's look at the query that I'm going to run. And we're going to use this index. We're going to look at that in a bit. But for now, let's just accept it as fact. We're going to run this query. And here we go. So here's the query. And there's apparently a single email that matched this query. But notice something interesting. You can see that this took 44 milliseconds to run. This is because this is the first time I run a query on this index for a while. Next time that I'm going to run, it's going to be much, much faster. Notice that I actually had to disable the cache so we wouldn't get the cached timed value. So this is interesting. We run a search on this. Now, if you come from a relational database background, you know that what I'm actually doing here is something like this. And running a query like that is insanely expensive on any realistic dataset. And the problem here is that you have to do a table scan, and there is no way to optimize that. RavenDB allows you to run those sort of queries far more efficiently because we're not expressing the query as containers. You can do something similar to that with Raven. You can do something like this. Which is effectively the same thing. And notice something interesting. The amount of time that the query takes is quite significantly more. We have to scan. If we do this, it's almost nothing. Now, I'm going to touch in a lot more depth on exactly why this is the case, but we'll get to that. Now, notice that I'm searching a term in a full text search query, but I also have this issue, this query. That is a lot more interesting from my perspective. Let's see exactly why. Now I'm searching for memo closure, and this is actually, you see that I'm getting quite a few results here. But this is interesting to me because what am I querying on? There is no query field in the messages. No query, nothing like that. So let's go and look at the index itself and see what we have. Sorry, I managed to drop the mic, but not the proper kind of mic drop. Look here. You can see that we're doing something quite interesting. We are indexing multiple fields, the subject and the body, as a single item. Why are we doing something like that? The reason that we do this is to allow us to search across multiple fields easily. If we go back here and run this query, we will be able to see that, okay, there is no memo here. Probably there is a memo or closure here somewhere. But the idea here is that I don't care where the value is. I want to be searched on across all of them. And that is a very powerful feature because it means that instead of offering you 10 different fields, put the query that you want in the subject, or maybe it's in the body, you don't care. How many times do you have some part of the statement that you want in the subject, sometimes in the body, or some form of mix of that? In other scenarios, it may be that what I'm actually searching for is something like, oh, you know what? I want to talk to some email from Fred about finance. And whatever this is. And now the ability to go through and query multiple fields in one shot is very useful because now I have a much better model for looking at the data, for throwing stuff that I don't care. I don't need to remember that, oh wait, was it a mail that I sent to friend or did friend send to me or those sort of things. Just Fred, it will find it regardless of where it's at. Again, depending on what you put in your query, but that's the whole idea. And it's very important that you don't have to model your document, your index to match your documents. You're free to do those sort of things, to modify and merge or split things as you see fit. For example, let's say that if I'm looking here, I want to be able to search for those. Right now, in the index that I have, I don't have anything here. Now, what we'll see here is that almost all of the emails that we have are from Enron. So I can just ignore that. Let's say that I want to look at those things. I want to be able to search for someone who was in this email. So let's see how I can do that. X.split. Okay, now what I'm doing right now is quite interesting. I have BCC, CC, and form. Now, notice what I'm doing here. I'm doing something completely and utterly ridiculous. And by the way, I just update this index. This is a big index. I'm running a whole bunch of other things on this machine. So you can see that I don't have a lot of space. Most of my memory is actually taken by other things, and RavenDB takes under 1 GB. So it's going to take some time to run this. But I'm doing a side-by-side update of the indexes, which means that I can still run queries normally with no issues. Now I can go here and query the new index, but it's still processing, so we let it on. It's important to understand that we can do some really amazing things with modeling the data in the indexing process to make it easier for us to find things. Now, let's talk about the process in general. How RavenDB goes from some documents to finding the details of your document. And in order to do that, we need to understand what it means, the notions of terms. So here we have all of the fields that we have in the index. In this case, this is a simple index. We have no dynamic fields, but you can see here all of the values that I have in the two. By the way, it looks like I'm not really processing everything. There are a lot of very interesting things. It's also very strange. But anyway, let's go to from. Here we go. At one point, I tried to write regex to process emails, and just looking at this makes me happy that I stopped doing that. Anyway, what you can see here is how RavenDB processes the values. Here, all of the unique terms that I have for the field, and you can see how I'm running that. Give me all of the messages from this guy, whatever that is. Apparently, EBS master agreement. I'm assuming this is not Elastic Blob Store given the relevant dates. Now, this works this is simple. The value that I have here, is what I have in the document. This works very well until one of two things happen. Either I'm doing some interesting processing here, or I defined advanced field options. When we index a field in RavenDB, this is just a start. This is what are the fields that we want to index. But notice that I'm in the two form are arrays. So they may have multiple values. This is an array, by the way. So what happened? We're going to say flatten the array. Go over each one of these values and index that as independent value for this field. And then we do this. We say, okay, the query field, I want to store that. I want to enable full text search, term vector, and indexing we'll explain later. But the most important thing is, how do I want to analyze the text? And what does it mean? By the way, notice that subject is also using standard analyzer. User, the only thing that I have here that is interesting is that I enable suggestions. That's good enough for now. Let's see what this means. What this means is that when I'm looking at the subject as a good example, I don't have any of the interesting subject. What are those? All of those? What is that? And let's see. And what we see here is that we're searching for O1 XLS, so some Excel spreadsheet. And this is the subject. Why, when we search for this, we get this? And the idea here is that as part of the indexing process, RavenDB applies an analyzer. And this analyzer is going to say something like this. Let's break this statement into discrete terms. The easiest way to think about it is that we're going to use, the terms are words. But this is not necessarily the case. For example, this is not a word. But what will actually happen is that we'll split it into individual terms and then start processing them. For example, in the case of the standard analyzer, we'll try to break it on word boundary. We'll remove the, here we have 9%. We're going to remove the percent. It's something that we don't care about. But if we have an email, we know that it needs to be preserved as is, stuff like that. The actual process of going from the raw text to the stream of tokens, that match, that are relevant for this particular value is non-trivial and quite interesting. Why is that? Because the process, this is how it allows you to search for all sorts of interesting things. For example, if I'm searching for running or runs or all sorts of stuff like that, it gives me a lot of capabilities, because what the analyzer can do, it can reduce a word to something called its stem, the root of the word. For example, I might have a word, and the easiest way is streaming. What is the root of that? Stream, the stream something, stuff like that. So I can narrow it to this. I have an interesting blog post. I have lots of blog posts about this, but this is a series of blog posts where I write a full text search engine one step at a time. And I'm going to post this at the chat for everyone. And we'll also add that to the show notes. But this goes to the basic process of how full text search works. You might find that interesting. At any rate, the whole idea is that we have the analyzer, it goes from the text to those terms, and then we're able to search on the terms. Because the idea here is that these terms, let's say social, give me the list of documents that has this term in them. And we can very easily and visually see that. Let's go and search for something that's hopefully going to be interesting. And that's interesting. I don't know what that is. Okay. So apparently, let's search for spider. Apparently, there are quite a lot of spiders here. Anyway, so the basic idea is that somewhere around here, we have the term spider, and I can find it. And the way that it works is to have the term spider, and then the list of all of the documents that contain these terms. Now, let's go back to here and try to understand what we're doing. Now, this is, we saw, so far we talked about relatively simple searches. What happened when what we want to do is more complex? So I want to search now for something like this, where the term is party. Now notice that I'm actually saying something really interesting. If this is on the subject or in the query, remember that the query actually contains the subject. So why am I doing this sort of query? Well, the answer is very simple. The answer is that I'm using a boost here. And why am I using this boost? The idea here is that if I find party first in the subject, I want it to be sorted higher. I can also do it more explicitly, like so. Or what I'm asking for now, give me terms, give me messages where there is a party in the subject or in the query, but I want to sort first where it find in the body and not in the subject. Let's see if I have spider here in the subject. No, nothing in here. So the idea here is that I'm able to express something really complex. I want to find the result wherever it's at. I don't care if it's found in the subject or in the body or wherever, but I have some sort of a ranking. If I have two messages that mention spider, I want to force rank those that in the subject more, because probably that has some meaning for me. If you go here, there you go. So apparently, lots of stuff about spiders. Now, that also leads to other important observations. For example, if I'm searching for this ranks higher. Why is that? And the idea here is that we are not necessarily going to have to search for an exact match. It's enough if I have a spider in here. Apparently there's a lot of, okay, so right here, I don't have anything about the spider. I have something about the Karen. So I find it. And the idea here is that it doesn't have to be an exact match. I'm expressing here the things that I want to find. RavenDB give it to me in the order of most likelihood to be what you meant. And this is a very important observation about search. I'm no longer asking for the exact thing. I'm saying here the criteria that I'm searching for, give it to me. But I have an issue. I might be getting too many details. So let's make it easier for you to find it by ranking them by according to how you do that. The actual process in which RavenDB does that is non-trivial. There is something called IDTFTF, and I'm trying to recall what the acronym stands for. So this is tail frequency, and this is TDF, something like that. So basically, there is the tail frequency overall, and there is a tail frequency in the particular document. For example, if there are lots of if there are also spiders in the corpus, in the text that we're trying to index, then spider is not a very meaningful distinguisher. But on the other hand, if spider appears a lot in this particular text, it means that it ranks higher. So there's a lot of moving pieces here. There are quite a few books and theses written about that. There is a really nice book that is called Managing Gigabytes. To be fair, it was written around the time where Enron was considered to be a very big data set. But it goes over a lot of the details about full text search that might be very interesting to you in general. Now, notice something really interesting. We have here the idea of include explanations. And you can see it here. Here are the results for this query. And here are the explanations. So you can drill down, and the idea here is that you can ask RavenDB, why this document? And okay, here is the weight of Karen, here is the weight of Spider, and almost of other stuff like that. And this is the reason it got this score. And you can, by the way, you can see here, I have Karen and Spider, and here I have just Karen. So I have a match, so that's why I have a better match. Another thing to notice is that the score is accessible to you through the API. There is not a lot that you can do with that, but it's still useful. You can also do more interesting things with regard to the score. So for example, you can do, I actually care about sorting first by date and then by the score. And so if I have things that are on the same date, then sorted by score, all sort of other interesting scenarios like that. A lot of that depend on the kind of search and queries that you need to do. In most cases, the more flexible you want things to be, the more helpful this is going to be for you. And the explanation is an invaluable tool for you to understand exactly what's going on and how things are working and stuff of this nature. Now, this is interesting. This is something that I actually spoke about quite a lot. And you can see here that I'm saying, okay, let's go all of the messages, the users, and all of the users who start with a particular prefix. Really, just farmer? But there are a total of 150 unique users in the entire dataset, which doesn't seem like a lot of people. But here is the idea. You can see how we can filter that, start with, ends with, those sort of things, give you a lot of flexibility. The idea here is that we are not actually processing the raw results. We're actually using this thing, which is a MapReduce index on the user property. So we have 517,000 documents that we have to process, but we already processed them and we can gather all sorts of interesting details about them. In this case, how many users, how many emails each one of them sent. And then I can do things like, such as use this query to do a filtering as you go. So give me the users who start with B, here they are, and I can show them to you, sort them by whatever, so you can search on them or do all sorts of other interesting things around this. The idea that we use the group by to narrow down the field, and then we are doing additional searches. This is something that is very common, both with the more complex indexes that we use, and with being able to reprocess the data, do MapReduce aggregation, those sort of things. But notice that this index is now completed. Here we go. Let's look at the terms we have for emails. And you can see that we have a whole bunch of interesting details here. As the good thing or not good thing about this data set is that it's not cleaned up, which means that you're going to get a lot of data that is dirty. And that's bad because, okay, it's not pleasant to work with, but it also means that you get to work with realistic data sets. And stuff of this nature, which is actually interesting. And let's search for this. Okay, so here we go, finding a user by name, doing the usual filter as you type. And again, because this is working on a MapReduce, this is going to be very, very fast. Now, let's look at this. This is when we stop just doing searches and start applying additional features to the query itself. So right now, I want you to focus here. By the way, as usual, the more work I do with a particular part of RavenDB, the faster it becomes. So let's go here and say closure, and things become faster and faster. Now, notice that here we have to split the manner that we work with the query. This is the filter that says, okay, what are the results that we want to find? But then we don't want those raw results. We want the fastest of those results. So in this case, here are the users who have email on memo enclosures or closures. And here are the date ranges where those emails were sent. So the idea here is that instead of just looking at the raw data, we give you the facets of the data, and now you're able to start doing more interesting filtering on that. For example, I can say, you know what? Now, obviously, I have only just this guy. Now I have apparently only sent it here. And with proper facets, you're able to give your user some really nice ways to slice and dice through your data. And that makes things a lot easier when, okay, I'm starting to write something, I'm running some initial query, And then it says, oh, I'm searching for a phone. It has to be unlocked. It has to be Android. I don't want something that spyware equal no, those sort of things. But I wouldn't necessarily think about all of those if I just had, here are the 15 different fields that you can choose. But once you presented this form, once you tell me, oh, you wanted a phone under $50 that are running with 32 gigabyte of flash disk and XL camera under $10 with no spyware, not going to happen. Those sort of things. Now, there are many cases where what I'm looking for is something that looks like something. And usually the way that it works is that you want something like this. Give me all of the documents that matches these other documents. So first of all, let's look at what this document is. And this is a document about update some global GIS information, whatever. Now I'm going to go here and query that. And it gives me some results, and I didn't like that the first time that it happened. It takes a while, etc. And we get some results, and you can see that some of them are very much, oh, update this. Some of them doesn't look necessarily exactly the same thing. Oh, wow, those are big documents. It takes me a lot of time to just open this. Now, the question is, what's going on when I do something like this? Why is it, yes, close this. What is the system doing? And the answer is that what I'm actually saying is, okay, let's take this index, this document, find all of the appropriate fields that I have, and then search on them. So it says, basically says, give me, and remember, we're going back to the terms. I've broken, in this case, I did it simply just on the subject. Let's take the terms that we have in the subject for this thing, and then just query on that. Now, in this case, and I'm just going to give up, and that's an issue with opening very large document. You can see that it really doesn't like me. Let's shut this down. Okay. Now, here we go. Now I'm going to go here, and this is, wow. Okay, that explains both why we have a slow indexing speed and why we killed it. Apparently, that's a whole bunch of what? I don't even know what this is, but whole bunch of something. Looks like XML. Not reading that. Anyway, so the idea basically, and let's make this simpler. Fields, subject. Now I'm asking only do this on the subject field. And you can see how it works. This is what we had. This is the, as I remember, this is the subject that we had originally. So what I'm actually saying, I'm saying something like this. Let's go here. Look at this index, this document. Here's the subject. And I'm effectively doing something like this. It's a bit more interesting than that, but that's the basic idea. So give me things that look similar. Okay, so this is a match on the complete. This is match without the reminder. this is, here is update and reminder, but we are missing the G's. You can see how it works. Once you, and the reason that I'm stopping to discuss this is that once you understand how it works, that this is roughly what's going on, there isn't much magic. But when you see it in practice, oh, give me stuff that looks like this, it starts to look very interesting. Now, why do I want to do something like this? I want to do something like this because in many cases, I'm not doing that on a single field. I'm doing that on a whole bunch of them. And once I'm starting to say, oh, it look roughly on the same same users, same tools, same form, those sort of things, you start getting into very surprises matches. Now, let's talk about this query. I want to find someone. So I'm going to search for them. I'm getting nothing. This is quite interesting. It was frustrating. I know what I wrote. Now I'm asking Raven, hey, can you suggest to me, I put smite D for user. What did I mean? And then, oh, there is no such thing. You probably mistyped. It also works very nicely when we have users who are actually with names, with streets, those sort of things, where you can provide some really on-point suggestions. And one of my clients once had this experience where they're providing a text field, and the user is searching on that. And if there are no results, then we're going to run the suggestion. And then we're going to show you the match based on the suggested data. And apparently the user has gotten so used to writing Smite and finding the right Mrs. Smith that he thought that this is how you write her name. And apparently that was a whole ping in the end, which I found to be very amusing in the end, because, oh, why did it find it? I'm trying to give you the right thing, trying to make it so you don't have to think or to spell properly. I know that this is very helpful for me personally. So this is just something that you do. You ask everybody, okay, given this thing, find me the matches for a user based on the actual data that we have in the index. And if you will recall, I actually enabled that directly here when I ask for, give me the appropriate suggestions. The way that it works is that we store n-grams of the value, and then we compare on n-grams, and then we do string distancing algorithm. If you care about, there is a documentation to go over that. In many cases, magic happens and we find you the right thing, especially if you don't involve the user in that. If I translate this query into this one, that's magic. And that works, and they tend to be very happy about that. Now, let's talk about the kind of queries that we are running. So we keep running into non-trivial queries, where what we are searching and what we are finding are very different. So for example, I'm looking at this, and we're searching for a performance issue. And that's a lot of data. Where is the things that I actually care about here? I don't know. I have to go and figure that one out. And if I want to show this to the user, that's really annoying. I can ask RavenDB, give me the context for this. In which case, it's going to say, oh, you know what? Here is issues. And you can see that it bumps that up for me. here performance, and etc. There's a whole way that you can control it, and instead of doing HTML, we'll do something else, but that's the idea. I can also do something like this and do a search for phrase. There are no let's see. Apparently there are no matches for this. Let's search for weekend out. And here, a whole bunch of other stuff like that. Apparently they had a lot of outages. So the idea here is that instead of asking the user to work hard, we can just run it with just run it and ask everybody, give me the information. We have questions from Anonymous. Will there be a record of this webinar? This person has to go, and yes, we will record it and we will make this public. And if you have any question, I know that I'm running through a lot of concepts, trying to squeeze a lot of information into just this thing, but feel free to ask. I forgot to mention, and I probably should have, we're running I'm running a workshop. David, if you can find where the link is for the workshop, but we're running a workshop next week that goes over about 2 days of everything that you wanted to ever learn about RavenDB. And in the meantime, let's go and move forward. Let's talk about this index, this query. And the idea here is very simple. The more work I ask RavenDB to do, the more expensive things become because I ask for more work. But actually, there's going to be a question, how do I find where the time went? This is where we have this thing. We can ask Raven, hey, you know what? This took some time. Why? And okay, apparently we spent a lot of time in the scene. Probably because of this. But we can once again run the query. We can see that the timing difference change. And okay, more stuff got put into memory. The more details we will have, the better things will be. Let's see, we have another question. Matthias is asking, will there be another workshop this year? I think this is the last one that we are going to do as a full 2 days workshop. We might do half days toward the November, December, but the full 2 days with the everything cover is going to be just next week. And okay. Okay, so now we can see that we have details about exactly what's going on, where things are going. In some cases, I might have see if that worked. And again, you can see that, okay, now JavaScript took a lot of time, just those things. So the more complex the query, the easier it is to actually understand and pinpoint exactly what's going on. And this is not meant to be the end all be all of profiling, but it gives you a very good indication about what's going on in the system. I am forced to point out that I'm running this with very little resources on a machine that also runs a lot of other stuff, but we're still getting acceptable performance numbers. Now is the time for questions. Feel free to ask whatever question you have. I will be very happy to answer. While I'm waiting for questions, I'm going to try to find the RavenDB workshop. We're doing that as part of the NDC. And here we go. I'm also going to add that to the chat, so you will have that link. And you can see I'm going to cover quite a lot of stuff here. What's important to understand about querying in general with RavenDB is that the whole idea is that the indexing gives you a huge amount of freedom. I focus in this webinar on full text search, the kind of things that you're able to do. But the indexes also give you the ability to run computation, all of the usual stuff around that. The RavenDB query language also has the ability to do things like this. Now you can run whatever Lucene query you have here. Something like that. And that gives you some information about what's going on. So we have questions from Adam. Are there any differences with full text search on languages other than English? And the answer is that full text search is very much dependent on the language that you're using. What do you mean by that? So for example, let's talk about I'm trying to remember. There is no. Don't want those things. I want the YUMLA. Okay, sorry, it's the B, not the C. So let's talk about this thing. So in full text search in German, I might have this term. And I might be able to write it. I know this is not how you do that in German or something like that. And all three of them would be equivalent. Again, don't get too hung up on this particular example, but the idea here is that the job of the analyzer is to normalize things. The standard analyzer that we use does pretty good job for most Latin-based languages, but there are also other things that you might want to do. There is the snowball analyzer, and what I'm searching for here is specifically the transformation that it's doing. And the snowball analyzer does, okay, I'm not saying there was a, okay. Hopefully that would be a better example. There we go. So the key here that you may have a lot of stemmer and analyzer based on the specific language that you use. This is a good example here. Another example might be again, in English, I might want to go from streaming to the term stream. And that's part of the work that I do in the language, in the analyzer. In French, I might want to go back to the root of the word, and French is more structured than English. That might be easier, those sort of things. With RavenDB, you have the ability to define which analyzer you want to use, and you can use custom ones, including the ones that are language specific. There are also ways of having allowing you to choose which analyzer you want based on the actual language in the field itself. That's a much more advanced feature. You probably don't want to get there, but it's also good to know that it's possible. Okay, more questions. Okay, oh, we have one from Rashid. If only watching this webinar before using the RavenDB search feature, your documentation is very nice, but watching you live is awesome. I will give you more details on the pain points and encounter by email. Thank you very much. I would be very happy to hear everything that you have to say, both here over the email. As a reminder, if you want to, we offer live demos. You go here, request it. We'll have someone come and talk to you, listen to exactly what you have to say, what is the scenario that you have in mind, explain to you exactly what RavenDB can help and how it can best fit into your environment. Another thing that we also offer is in the cloud. You can just provision a free RavenDB instance. You don't even have to give any critical information, and you can start using RavenDB within a few seconds. And as usual, if you have any question whatsoever, get in touch with us. We will be very happy to hear from you. If there are no more questions, I would thank you very much and have a great evening. Goodbye.